So figures are basically formed when you take a region that's enclosed by a boundary. So it's basically the key is figures are just enclosed. They're a combination of elements that enclose a region. And the figures that we're going to talk about here kind of form the basis for what we'll be looking at in the next, or in the middle to end of the textbook itself. So we'll begin with figures that you can form using one single consecutive line, and that figure is a circle. Okay, so a circle is thought of historically as being the region enclosed by a single consecutive line. When lines were defined originally, they didn't specifically have the straightness condition to them. It simply meant any element that if you take that element, any part of that element, and you place it back on anywhere on the element itself, it's the same thing. Well, circle fit that definition. So you could take any piece of a circle, however long you wanted to take it, and you could remove that piece and then place it anywhere on that circle, and it would map on or be superimposed directly onto that figure. So it was defined as being a figure enclosed by one single line. Okay, but the way that we think of the circle is a set of points that are a given distance from a fixed point. Okay, now, this definition is somewhat incomplete, and I left a space here to fill in to talk about how to complete this definition. But before we do that, I do want to talk about the definition here is the set of points that are a given distance from a fixed point. Well, what do we call this given distance here? A radius. Okay, and radius is just designated with the letter R. And then what is this fixed point called? In a circle, it's called the center. All right, so when we look at our definition, it's really showing the radius and the center. Hey, but if you were to take the definition as I have it written up here, so it's, again, not quite complete yet, but the set of points that are given distance from a fixed point, well, that would include points that are that same radius, but that stick out from the wall, right? It would also include the points that are that same fixed radius, or that same given radius that are in behind the wall. And so really what we have here is the definition for a three-dimensional circle, which is called a sphere. And so in order to make it fit the circle, which is 2 dimensions, what word can we use here to put conditions on or qualify the type of points that we're looking at? What kind of points do they have to be? Okay. Good. They have to stay in one plane. And so the word to complete this definition will be coplanar. Okay, be very careful of it. The reason why I'm specifying this is you will see something like this on quizzes, tests, or finals. This almost exact same question. Be prepared to distinguish. If it doesn't say coplanar points, it doesn't mean circle. All right, there's a couple other elements in a circle that you do need to be somewhat aware of. The first is if you take a segment and extend it from the center to the circle itself, that's the radius. But if you take a segment and extend it so that its endpoints both lie on the circle itself, that's called a chord. If you take a chord and you extend that chord so that it passes through the center of the circle, okay, so this is still a chord. It has endpoints on the circle itself. Okay, so this is still considered a chord, but it also more specifically can be classified as a diameter. So any chord that passes through the center of the circle is considered a diameter as well. Okay, the points that make up the circle if you were to measure the distance to travel around those points, is called the circumference. Okay, so the circumference is just the distance of, or the length or perimeter around that circle. Okay. Terminology-wise, that's all I want to go through here. Once again, we'll talk more about circles in Chapter 4. Okay, so that takes us to the figure we can enclose by two distinct lines. So this is one distinct line. If we take two distinct lines, so if we take the portion of a circle that's cut off by its diameter, what shape do we have? Semicircle. Okay. The definition of this term is built into the word. Semi means half of a circle. It's a set of points that are contained on the diameter and the portion of a circle that are cut off by that diameter. Okay, so basically it's half of a circle. Okay, when you talk about the semicircle, it's the entire thing. So it's this whole curved portion. That's line 1. Line 2 is this diameter. So a semicircle is still going to have a center. It's still going to have a radius. And it's still going to have a diameter. It is the only figure whose center will lie on its perimeter. And once again, we'll talk more about a semicircle in Chapter 4. And this is all that you need to know, or as far as just this basic terminology of it.